This is chapter 6, problem number 36. The lucky number for this one is 2. Number 2 is the lucky number. It says a 0.48 kilogram ball is thrown with a speed of 8.8 meters per second and an upward angle of 36 degrees. What is the speed at its highest point? All right, so let's look at this one. Well, the second one is how high does it go? Okay, so if the ball is thrown up vertically, what will happen? If we throw up vertically, we have an initial velocity, and when it reaches the highest point, that means it will stop and then come back. So that would be the cycle. Now, what happens if we throw the ball instead of vertically up, we throw it in an angle? Okay, so at the highest point, will it stop? It will not stop. Okay, it will stop in the y direction, but it has two components in it. It has both the x component and the y component. So it will keep moving at the constant velocity in the x direction. Let me repeat what I just said again. If we throw the ball up vertically, the highest point, the kinetic energy will be 0 and it will be coming down. If we throw the ball in an angle, at the highest point, it will not be stopping there. It would be still moving in the x direction. Okay, so we will be using conservation of energy and try to find out what the kinetic energy is in both cases and what the potential energy and how we can relate them and solve for the speed. All right, so before anything, okay, if this angle is 36 degrees, what we need to do is we have to analyze its component. If it's 36 degrees, so what we have learned before, it is the velocity in the x direction is equal to the velocity times cosine of theta, that means cosine of 36, and that is equal to 8.8 meters per second. Since it's a standard unit, so I don't need to write down the unit, times cosine of 36, and that is equal to 8.8 times cosine of 36, 7.12 meters per second. Okay. We can do the similar thing for the y direction. Okay, Vy initial will be equal to V initial times sine of 36, and that will be equal to 8.8 times sine of 36 degrees, 5.17 meters per second. Okay, there is a way to check if we have done it right. So Vx squared plus Vy squared should be equal to V squared. Okay, as an exercise, you can check about it. All right, so over here, I'm trying to do the conservation of energy. I try to do before and after. Before, when it's over here, what would be the kinetic energy? Kinetic energy is equal to, so kinetic energy plus potential energy, it will be equal to kinetic energy in the final state plus potential energy in the final state. So we have initial should be equal to final. That is the concept of conservation of energy. Initially, kinetic energy is equal to half mv squared. V is the velocity at the beginning here. Okay, that plus, what is my potential energy here? Is equal to mgh. So I'm going to write down kinetic energy is equal to half times mv squared. Potential energy due to gravity is equal to m times g times h. M is the mass, g is gravitational constant. It is 9.8 meters per second square. H is the height. Since initially it was on the ground, So the height is 0, so potential energy is 0 here. That will be equal to kinetic energy at the highest point here. In the vertical direction, it should be 0, but it's still moving. How fast is it moving? It's moving at 7.12 meters per second in the x direction. So kinetic energy is not equal to 0, but equal to the velocity moving at this point, only with the x direction. Half times m, v is vx, 7.12 square, plus potential energy. Okay, potential energy over here is is equal to m g h. Okay, now it's looking for the speed at the highest point. Okay, do we know the h? We don't know the h. Okay, so what can we do? We can find out the h. Okay, well, at least we know the speed. Okay, so the speed at the highest point we already calculated. We try to solve for h over here. All right, so instead of writing the v, I'm going to plug in number now. I'm going to plug in 8.8. 8.8. I see a term 0 here, so I'm going to erase the term 0. Okay, I see the m everywhere on each term, so I'm going to erase the term m. I can cancel m on both sides. That means it will be independent. It will be independent of the mass. That means the ball, if it's 0.48 kg, it doesn't matter. Okay, if it's 48 kg, it still will go with the same height and with the same velocity. All right, so I plug in everything. Okay, I cancel out the m. Okay, so now I'm going to plug in everything and try to solve for the h. Okay, so half times 8.8 square, so 8.8 raised to, and then times a half. So on the left side, I have 38.72. That is equal to 7.12 square, and then times a half. Okay, so that is 25.35. Okay, plus 9.8 times h. Okay, so what I'm going to do is I'm going to minus 25.35 on both sides and then divide it by 9.8. So it will be 38.72 minus 25.35, and then I divide it by 9.8. Okay, so I get 1.36. So h is equal to 1.36. Okay, so the height here will be 1.36 meters. Okay, there is another way that we can calculate it. Okay, let's say we did not learn the conservation of energy. How are we going to do it? Okay, so I'm going to use another method over here and I try to calculate it. Okay, so now I'm only using, I want to know the height. Okay, at the beginning of this course, we learn about the height. If you know the acceleration, okay, so one of the master formula is v final square minus v initial square, that is equal to 2 times a times d. Okay, that's the formula before. Okay, so this d is the same as our h here. So what I'm going to do is this v final for us is the y final velocity, so it's 5.17 square. Okay, that's v initial. Okay, v final is 0, so 0 square minus that square, it is equal to 2 times negative 9.8 times d. Let's see what the d is now. Okay, so 5.17 divided by 2 and then divided by 9.8. Okay, so what I get is 0.263. Okay, so this one is different from the one that we get. Let's see, oops, I make a mistake. There's a square here. Okay, so I do that again, 5.17. Oh, when you do it, you may make the same mistake as I did. I forget to square it. Okay, so 5.17 raised 2, and then divided by 2, and then divided by 9.8. Okay, so I get the same answer. Okay, I get the same answer as 1.36 meter. Okay, so if we use two different ways, we can still get the answer. The lucky number for this problem is 2.